Zookeeper guarantees. These are the mainly five Zookeeper guarantees. The sequential consistency. Updates from a client will be applied in the order in they were sent. The second one is atomicity. It updates all the updates and or fail. No partial updates are succeed. The single system image. A single client will see the same view of the service regardless of the server that it connects to. The reliability. Once an update has been applied, it will persist from that time forward until the client's updates overwrite. The last one is the timelineess. The client's view of the system is guaranteed to be up to date within a certain time bound. Uh, Zookeeper primitives. The first primitive is the configuration management. It is used to implementation of the dynamic configuration in a distributed application. The configuration is stored in the Z node ZC. These are the diagram of the configuration management. These are the configuration data and the Zookeeper service, and these all are the clients. The client connected with the Zookeeper service with the watches. The watches help to the set notified when the configuration is updated. The client is reset the watch when it's read all the configuration and takes the appropriate action. The another primitive is a randomness errors. It's not it's defined as a not clear how to final system configuration might look like. The scheduling is done by the rescheduler and use the Z node ZR. The client does not know the addresses and the port that work process used to connect to the master. A master fields is ZR and its address and ports it is using. And this is the last one, is the group membership. The group membership is the ephemeral node to implement group ephemeral node for the group membership. The Z node represented by the ZZ. It's a representative group. When a process of a member of a group start, it makes an ephemeral child under the node ZZ. Like the worker and the worker 1 and the worker 2 is the children of the worker. It's the ephemeral node. If a process has a unique name or identifier, the name is used as the name of the child Z node. Like the same, worker and the worker 1 and worker 2 are the same identifier name as the server name in the group. This is the API of the group members and the server name. Now we see about Zookeeper implementation. This is the Zookeeper service diagram. Here three processes are done here: a request processor, atomic broadcast, and the replicator database. The request processor send the transaction to the atomic broadcast, and atomic broadcast send the transaction to the replicator database. Request processor works as a converts the idempotent transaction into the atomic broadcast. The atomic broadcast atomic broadcast is the cluster. It's the one of the node as a leader role and the rest have follower roles. Here is the leader and the other two are followers, which are connected with the client. The leader is responsible for the all accepting nodes and the change from the clients and replicated them into itself and the followers. The read request and are load balanced between the all followers and the leader. Replicated database. Each replica has a copy in memory of the Zookeeper state. Whenever Zookeeper servers recover from a crash, it needs to recover this internal state. We could replay all the transactions in write ahead log. This would be slow. Instead, periodically take snapshot of memory in database. The fuzzy snapshot because Zookeeper state is not located to take snapshot. That's why the snapshot contains some subset of transaction during the snapshot generation. We can later apply transaction delivered during snapshot generation. If we apply transaction twice because transactions are idempotent. The client server transaction. When a server processes a write request, it also sends out and clears the notification related to any watches. Process writes in order. The read request is processed locally at each server and tagged with a ZX ID corresponding to the last transaction seen by the server. The fast reads means no guarantee of precedence order of a read operation can return a stale value. Uh, the sync is used for the handling this, and the client calls sync followed by the read operation. The FIFO ordering of client coupled with the global guarantee of sync enables the result of read operation to reflect any changes before you send and sync. So here is conclusion. The Zookeeper is a very user-friendly interface and simple interface. It's a powerful abstraction of the high throughput for the heavy workloads. It's used in a real workloads, and the another property is its weight-free property because useful high performance. And this is all our references. The main references is the Zookeeper weight-free collision for internet scale system for Yahoo research paper. This is the main research paper of our presentation. So this is how conclude. Thank you. Any question?